Hello guys, and welcome to my math tutorial video on the unit circle. So the first thing you have to know about the unit circle is that the radius from this point to this point is 1. So from the origin to the x and y axes equals 1. And from there we know that since the x-axis is 1, that means that the coordinate to here is 1 and 0. So if we know that this coordinate is 1, 0, then we know that the y-coordinate on the y-axis is equals 0, comma 1, because the length from here to here is 1 unit. And then that goes the same for here, although this one is 0, and because it's on the negative x-axis is -1. And same for the bottom, the negative y-axis equals 0, -1. Now that we have established that the radius of a unit circle is 1 unit, I can now find an angle, so I'm going to draw an angle right here. And notice on the unit circle, a positive angle goes in the counterclockwise direction, while a negative angle would go in the opposite direction. So this angle starts with the initial side, which is on the x-axis right here. That would be the initial side, and the ending side of the second line would be the terminal side. So let me write terminal. And of course the angle, or whatever the angle would be right here, would be theta. So next what I'm going to do is I'm going to make another line, drop it right here and make it 90 degrees parallel with this line right here. So if we were to make a point right here, its coordinates, let's say it would equal A and B. So this side right here, since it's on the y-axis going up, would equal B. And likewise, this would equal A. And of course, this line right here being the same size as here, which is 1, this would also equal 1 unit. Okay, so now that we have defined our coordinates for this certain angle, we could write our trig functions. So this is a right triangle right here, so we could use regular right triangle trigonometry. So okay, so sine of theta equals A over 1, which equals A. So actually it's cosine theta equals A over 1, because if we look at the triangle, cosine was adjacent over hypotenuse, because that's right. So of our basic trigonometric functions, so cosine adjacent over hypotenuse. So adjacent is A over 1, which equals just A. And same as sine theta equals opposite B over 1, hypotenuse. So that would equal b over 1, which equals b. So if we think of it here, we could come to a conclusion that sine theta equals the y-axis of the triangle, while cosine theta is equal to the x-axis. And same as tan, tangent theta equals opposite over adjacent, which is b over a. So now that we know how the unit circle works, I want to go back and address the a regular triangle with functions so and so for theta, if this were to be a and 1 and b, just as before, cosine theta equals a, and sine theta equals b. And so this works for a regular trig function on a regular triangle with theta being less than 90. However, when the unit circle comes in handy is when this theta exceeds 90 degrees, or right, so up until learning about the unit circle, this is how we'd usually define a traditional triangle with a 90-degree angle. So we'd use SOHCAHTOA, which means sine equals opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent. So cosine theta would equal a, sine theta would equal b if this was a over 1 and b over 1, and tangent theta would equal b over a. And this is fine for a regular trig function, but so this way of doing it would be fine. However, on the unit circle, as we see here, we can now define different angles from the middle of the circle in different quadrants. So this would mean, say if we have this angle where this is theta, we're now in quadrant 2, where this is still 1, however, this is -1 and 0. Therefore, our trig functions could come out negative. So say this was -a and b, because -a from theta is negative on this graph, if you're going to think of it as a graph. So therefore, cosine theta equals -a. Also, one thing to note about the unit circle is that every single angle in the unit circle, the y-axis will always be perpendicular to the x-axis, because it's a measure of the y intercept. So now that we've got the basics out of the way, I'm going to show you guys how to define the whole unit circle. Right, so first you'd start with your initial angle, which would be 0 degrees, and then you'd work your way up. So if we were to go 90 degrees, we'd end with the y over here. So this would be 90 degrees. And in radians, pi over 2. So pi over 2 in radians and 9 degrees, because we moved counterclockwise to the positive side 90 degrees. So we'd end here. And then we can move another 90 degrees to get 180 degrees. And in radians, that would be pi. And then once again, we could go another 90 degrees to get 270 degrees. And 3 pi over 2 radians. And then we could get 2 pi radians and 360 degrees, because it's now gone in a full circle. So we started with 0, gone 360 degrees. Alright, next we could find this middle angle here by, since we know it's in the middle of 90 and 0, we could just divide 90 by 2 and get 45 degrees. And in radians, that would be pi over 4 degrees. Also keep in mind, now this angle right here, as defined in the unit circle, is 30 degrees. With 15 degree gap in between here and here, because these two are the same. So that's 15, 45 equals 60 degrees. So 30, 45, 60, and 90. And this in radians would be pi over 6 and then pi over 3. Then from here we could start solving for the rest of the circle. So first we could do pi, or 90 plus another 30 degrees would be 120, plus another 15 degrees, because this is the same gap as here, 15 and 15. That'd be 135, 150, and then 180. And we'd continue 180 plus 30 equals 210, plus 15, 225 degrees. And 240 degrees, 270 degrees, 300, 315, and 330 degrees. Now for radians, all we have to do is pi over 2 and add pi over 6 radians to get the point right here. So that would be 2 pi over 3, because we do pi over 2 plus pi over 6, and pi over 2 plus pi over 4 equals 3 pi over 4 radians. And then here for this one, you could just do pi minus pi over 6, which equals 5 pi over 6. From here we could do pi plus pi over 6 equals 7 pi over 6. Pi plus pi over 4 equals 5 pi over 4. And then 3 pi over 2 minus pi over 6 equals 4 pi over 3. And then 11 pi over 6. Seven pi over 4, and 5 pi over 3. So after we've solved for each of these angles, theta, now we could start finding the points that each one of these lies on. So the point right here, 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 and so on. So remember that earlier in the video, the x equals cosine theta and sine theta. So using this information, we could determine Alright, so now we're going to begin solving for the coordinates of each angle. So we can start with 30 degrees and pi over 6. Remember that as early in the video, x equals cosine theta and y equals sine theta. So if we take the first angle and draw it out, theta equals 30 degrees, and this is just 90. So to find the coordinates cosine theta and sine theta, we could just plug that into our calculator. So cosine 30 and sine 30 degrees, and we get rad 3 over 2, comma 1/2. So now we have established that coordinates to the first point, 30 degrees and pi over 6, is rad 3 over 2 and 1/2. Now we can start solving for 45 degrees and 60 degrees. So we could punch that into our calculator. Cosine 45 equals rad 2 over 2, and sine 45 equals rad 2 over 2. And this is the same because if you think about it, if we draw a line straight down, this would be a 90-degree angle. But since it's half of 90, we know that these two, let's say this are A and B, would be the same length. And then next we could finally solve for 60 degrees, which equals 1/2 over rad 3 over 2. We could find this by, if we look here, this is a 30, 60, 90 triangle. So 30 degrees right here, 60, and then of course 90. But if we see, it's the same as this triangle right here. And then knowing that, we could just flip these two values to get 1/2 and rad 3 over 2. Now that we've solved for the coordinates of each of these in the first quadrant, we could solve for the rest in the other 3 quadrants. Now now we have to remember that in quadrant 1, the x and the y are both positive. And the second quadrant, the x is negative and the y is positive. Because if you see, we go to the left of x, or of the origin in x. So this would be negative, but the y is still positive because we're still going up on the y-axis. And quadrant 3 would be negative for both x and y, because we go down on the y-axis and then again to the left on the x-axis. And quadrant 4 would be positive x-axis and negative y. Then from here we can just fill it out. So here we'd see, since it's a negative, it would be -1/2 and rad 3 over 2. Because this is the same triangle here as this side, but just flipped. The only difference is that it's negative x, because it's in, it goes from the origin to the left, which is negative. And same with here, we're just changing the x-axis to negative. So this would be negative rad 2 over 2, comma, rad 2 over 2. And then again, negative rad 3 over 2, comma, 1/2. And the third quadrant, both of them are negative, so we could do negative 1/2, or I'm sorry, negative rad 3 over 2, comma, 1/2, comma, negative 1/2, negative rad 2 over 2, comma, negative rad 2 over 2, and then negative 1/2, negative rad 3 over 2. And for here, it's the y that's negative, so this would be 1/2 negative rad 3 over 2, rad 2 over 2, comma, negative rad 2 over 2, and finally rad 3 over 2, comma, negative 1 over 2. And of course, this would be 1, 0, 0, 1, because you go up on the y-axis, and then negative 1, 0, and 0, negative 1. Alright, now I'm going to do some examples on how to use a unit circle to solve these trig functions. So the first thing we're going to do for number 1 is to find the location of 5 pi over 6 on the unit circle. So you can do this just through memorizing where each of these points lie on the unit circle. So 5 pi over 6 I know lies, if I were to draw a small unit circle right here at this angle. And from there I know that this angle right here equals, or this side right here equals negative 1/2, and the y-axis equals, I'm sorry, this equals negative rad 3 over 2, and this equals positive 1/2. So now, since this is theta right here, we need to find sine. So sine equals opposite over hypotenuse. So opposite over hypotenuse, which the hypotenuse is 1, so this would just equal 1/2. For the second one, again I have to find the location of 3 pi over 4, and I know that is right here. So this is theta, and this side would equal, so the hypotenuse is 1, this side would equal negative rad 2 over 2, and rad 2 over 2. So we're finding tangent. So tangent is opposite over adjacent. So this would be rad 2 over 2 over negative rad 2 over 2. So tangent 3 pi over 4 equals 1. Negative 1. Alright, next we'll do secant of pi over 6. So first we have to find pi over 6, which is right here. So this side is rad 3 over 2, and this side is just 1/2. So secant, we know is 1 over cosine. So if cosine equals rad 3 over 2, because adjacent over hypotenuse equals rad 3 over 2, then we know that 1 over cosine equals 2 over rad 3. So secant equals 2 over rad 3. Alright, for the next one, we're doing the same thing except for we're trying to find the angle in degrees. So 180 degrees would be right here. So therefore cosine, the point for 180 degrees is -1, 0. Therefore cosine of 180 would be -1. For this one, sine 225, find the angle sine 225, which is right here. And this side equals negative rad 2 over 2. And this is negative rad 2 over 2. So we're finding sine. So theta is right here. Sine would be opposite over hypotenuse. So sine would equal negative rad 2 over 2. And finally, cotangent 240. All we have to do is find 240 on the unit circle, which is right here. So this side would equal a half, negative half, and this side would equal negative rad 3 over 2. So we want to find cotangent. So tangent equals opposite over adjacent. So cotangent would be the opposite of that. So it would equal adjacent over opposite. So adjacent is -1/2, and opposite equals negative rad 3 over 2. And if you put that in a calculator, you should get to solve this, you just do -1/2 times the reciprocal -2 over rad 3. So the 2's cancel out, and you're left with 1 over rad 3.